Okay, trying again here. Last stream didn't work out so well. So today is August 12th, 2024. It's about 2:19 p.m. Pacific Standard Time. And I wanted to go over some earthquake forecasting data that I'm looking at, especially for my friends and family here in Southern California, because that's where I live. So let's get right into it here. So the first thing, we're going to start where we always do at Solar Dynamics Observatory, and we're going to look at the sun in two different angstroms of light, 193 and 211. 211 is probably my favorite when looking for coronal holes, which are these dark spots up here. They tend to pop out more in this angstrom of light, but this is also important because we can get a better idea of these areas that aren't quite coronal holes, but where the coronal field is less prevalent. So this is what we're looking at. It's an extension of the northern solar polar field, and the part of the solar cycle that we're in right now means that this is of negative magnetic complexity. Typically, historically speaking, from what I could tell by looking at other data that we can go over at another time, this red area up here is negative magnetic polarity, and the bottom is positive. Now, the sun's magnetic poles flip every 11 or 12 years or so. There's a 33-year solar cycle, and these actually change positions. So sometimes the southern solar polar field will be red, and that'll be negative magnetic forces coming off of it. So, but right now, the coronal hole that we're looking at is an extension of the northern solar polar field, and it is of negative magnetic complexity, meaning that it's the more powerful of these two. So we'll go over here to the Earth wind map. So this is something I wanted to focus on Southern California for this one, because we've been getting some shaking lately. The first set of shaking that we got, there was a 5.5 magnitude just outside of Bakersfield somewhere, I believe. You can correct me in the comments if I'm wrong. I'm kind of just spitballing here and freestyling, if you will. So what we look for when we see these coronal holes facing Earth, let me go back here, is this means that there's unmitigated solar wind and solar forcing and charged particles coming off the sun. You see this kind of like aura around the sun. That's a representation of the coronal fields, and they're these big overarching fields. So a lot of times when stuff you see, it'll get ejected off the sun and then it'll come right back to it. That's because of the coronal fields. It's a strong electromagnetic field around the sun that keeps in a lot of those coronal mass ejections and solar forces that go out into space and to Earth and other places in the heliosphere. These coronal holes, these dark areas are coronal holes, and what that means is that they're gaps in the sun's corona. So these blue lines right here, this is the sun's corona, and these are those fields that I just mentioned. So you'll see like the sun's coronal field extends way out past the sun over here, right? So if something gets ejected off the sun, like if there's a solar flare or coronal mass ejection, you'll see stuff fly up in this area and just come right back down. Some parts of coronal mass ejections and solar flares will escape, but if you ever see them live in action, oftentimes you will see a big chunk of stuff fly off the sun, and most of it will go down, but then a piece of it will actually continue to break off and go outside the sun's coronal field. So you see how there's no blue lines right here, and this is where we see the coronal holes. That's why we call them coronal holes. They're gaps in the field. So if there were something to eject off the sun, or just the standard solar wind and all these massive amounts of energy and charged particles that come off the sun, there's nothing to mitigate these forces. So they just fly out into space with nothing holding them back. This is, in my opinion, and just from me doing this for about 13 years now, when we see coronal holes coming down towards the sun's equator, see, because as we're facing the sun from Earth, the sun's equator is the plane in which the Earth is out in space. So the closer these coronal holes are to the sun's equator from our vantage point, the more those forces coming off the sun are going to affect the Earth, the Earth's interplanetary magnetic fields, the global electric circuit, all that stuff. So this isn't coming all the way down to the equator, but you also have to understand that in space and with the sun and stuff, things don't just fly off in a straight line. they just go wherever there's the least passive resistance, right? That's where you get like the strongest stream of those forces of charged particles. So it is extending far enough down. This is the northern solar polar field. The coronal hole itself is extending down pretty far. And I do think this is going to affect Earth. We've already been seeing some unusually, higher than average shaking in Southern California. But what we've also seen is that we have just experienced or are still going through some geomagnetic instability here. And let me show you what that looks like. So we go to the planetary KP index. See how high that is? That's actually that's pretty high. So anything below this KP index 5 right here is normal. So anything above 5, we call that a geomagnetic storm. So if you look down here, see KP5, right here at the bottom of the screen, if you could see, in green, KP, anything less than 5 is considered normal. Anything at KP5 is considered a level 1 geomagnetic storm. And then if we come up here to KP6, that's level 2, and so on and so on. So we got all the way up to 8, which is a level 4 geomagnetic storm, which is pretty significant. And what that means is that all that energy from a solar flare coming off the sun, it contains charged particles. And there's a couple things that happen there, but one of the things that happens is that it compresses the global electric circuit. There's always charged particles in our atmosphere, magnetosphere, ionosphere, going all the layers of the atmospheres up in the Earth. And when we get hit with a blast from the sun like that, what it does, and you can find visualizations of this online, is that it compresses all those layers of the atmosphere down. And what that means is that all those charged particles in every layer of the atmosphere they're already headed down towards Earth, but they start heading down towards Earth in a much quicker fashion, which triggers an electrical circuit, which we'll go over in a second, from the lithosphere, from outgoing long-wave radiation anomalies that are emanating upward from underneath the Earth's surface. But we'll get to that. I don't want to get you guys lost in the details here. So this is what we're experiencing right now. And it's really tough to tell with the satellite data we have now. There are times where I feel like geomagnetic instability has actually given us a little bit of a buffer so that we would actually be less likely to see major earthquakes. But at times, that's not the case, because sometimes the energy transfer of all those charged particles colliding doesn't occur up in the atmosphere, and it actually occurs lower, like at the lithosphere, the surface of the Earth, if you will. So, it's sometimes we get solar flares, coronal mass ejections that are headed towards Earth, and it does, in fact, seem to trigger a lot of seismicity around the planet. However, there are times where it seems like the opposite is true. So nothing really solid there to go by, but we are having some geomagnetic instability. And I believe we just got a third or a fourth solar flare that's going to be headed towards Earth, and hence why I'm talking about all this today. Because we got another 4.4 today in Highland Park, I believe, which, little personal note here, I was living in Highland Park when we had a major earthquake, I believe in October of 1989. I was about 10 years old. Anyways, moving on. So we have all these particles coming towards Earth. And so if we want to get an idea of where these particles are going to travel, we go to the wind map over here at earth.noschool.net. If you guys want to follow along here, there's this menu right here. And if you go into the overlay, you just make sure you select the MSLP, which stands for mean sea level pressure. That's the wind map we look at. And so what you're looking at here is these gray areas right here are high pressure cells. I'm sure you've heard that term before. The yellow areas as they're traveling downward, and then these purple areas are the low pressure cells. So when we see coronal holes and we see all this energy coming off of the sun, and we feel like there's going to be some large seismic events or earthquakes being triggered, we want to find out where these particles are going to charge, or where they're going to be clustering up and headed towards the surface of the Earth, which again, we'll get to the upward emanating charged particles in a second, but I just want to cover this real quick. So we get all these charged particles from space, whether it be a solar flare or just unmitigated solar wind from a large coronal hole that's facing Earth. We want to find out where on Earth are these things going to go? So what we want to look for is we want to look for high pressure cells, these gray areas, feeding into these purple areas, or the low pressure cells. So it's not just low pressure cells anywhere in the Earth. What's not on this map are plate boundaries. So, you know, I'm sure you know that the Earth has many plates, and there's plate boundaries, and there are fault lines that emanate and sort of branch off these plate boundaries. So I'm sure a lot of you know on the US West Coast, there is a big plate boundary right here. It comes down in here, and then it cuts across over here and goes down into Baja in this area right here. And this is what we look for. We look for low pressure cells that are near plate boundaries. Like, for example, there's plate boundaries over here by Japan. Japan, I would say, is probably at a higher risk. Even though they just had a large earthquake, they're still at a pretty high risk because they have all these low pressure cells off the coast, and these aren't that far from those plate boundaries in Japan. Same down here in Indonesia, this area right here in the Philippines and Papua New Guinea, all the way over here to Vanuatu. You can see that kind of stuff as well. And let's not forget South America. The west coast of South America has large earthquakes a lot more frequently than in North America, like where we live up in the United States. But see, there's some low pressure cells here. And this high pressure cell is feeding all these charged particles straight into here. So I would put this area at risk too. So right here, this is not very common to see this much purple in this area of the western coast of the United States. And that would explain the increase in seismicity, because we have all these things lining up. Starting from the top again, we have the large coronal hole, Earth facing, right? This one probably isn't affecting us yet, but we had all those solar flares and coronal mass ejections that are coming off the sun, which contain those same charged particles and solar wind and all the dynamic solar forces that we talk about that trigger large earthquakes. And then we see that it's coming down into these plate boundaries that have low pressure cells near the plate boundaries, because all those charged particles from the sun are coming from space into these high pressure cells and then feeding into these low pressure cells. So then the next thing we look for is, well, what exactly are those charged particles going to be connecting with? So the only data we really have, and it's not the most reliable thing in here, as you can see by the date, this drives me nuts. I'm telling you, all of you, this frustrates me more than anything when trying to forecast earthquakes, is that we don't get updates in time. Everything on the daily OLR anomaly chart is a day old, and these things do move around and they do change in strength. And if we don't have, quicker updates on where all these things are emanating from, it's harder to get an accurate forecast as far as location is concerned. But this is the best we got, so we're going to look at this a little bit bigger. So what we look for is these deep red areas. And what this represents is the global electric circuit has polarity, and it also has upward and downward force. So we get all this electromagnetic forces and charged particles coming from space, and a lot of those bounce off our magnetosphere. It's our shield, but a lot of them break through. And what those particles do is they come down, they go into the Earth's surface, they go beneath the Earth's surface, and then they begin to emanate upward very slowly. And that's what the daily OLR anomalies are, is they show the areas where there is a large concentration of charged particles emanating up from beneath the Earth's surface into the surface and up into the lithosphere. And so we look for these dark areas, the dark brown and the dark red areas. Dark brown is positive polarity, I believe. Again, if you guys know better than me, you can correct me if I'm wrong, but I'm pretty sure that's what it is. And then the darker red you go, that's negative polarity. So these are the stronger ones. So based on the OLR anomaly data, right? Let me just, I can do this without getting that thing in the way. There we go. What we could do is we could look at, so I would put that area like north of New Zealand on alert. I think this is actually pretty far from New Zealand. This is more like Vanuatu, Fiji, actually. Yeah. It's out in the ocean. Probably not too big of a concern. But what do we see over here? Now, it's not deep red. But if you look, this area, this is relatively significant. I mean, there's a lot of places that get these that don't have earthquakes, but because we just had large earthquakes, we have low pressure cells right there. and all these forces coming off the sun, plus more forces on the way from another solar flare and the coronal hole, there's a lot of things right here to indicate to me that the chances of getting some large seismic activity on the US West Coast, particularly in Southern California, is unusually high right now. All right, let's get out of here. And this is just something fun to look at. It doesn't really help that much, but this is the total electron content inside the Earth's atmospheric layers. The red ones obviously being the strongest. So this was a few days ago, and as it gets more apparent, and you could see that it kind of gets stronger and weaker in these areas right here, but this doesn't really help us out too much. So let's get to the fun stuff. So this is USGS. There's the United States Geological Survey. This is where you can get a lot of your earthquake data. As I'm sure a bunch of you know, this is the earthquake maps, and close that out. So I have the newest ones first. So this is, in sequence of time. Now, I'm not seeing a very large cluster. Like this is definitely higher than average seeing this. This is not something that is very common in Southern California. It's not super rare, but relative to somebody like myself who looks at this stuff every day, this is not very common at all. So it is of concern. And if we zoom in a little bit, this is the one in Highland Park. And there were a few more. These look like aftershocks of that 5-pointer we had in Grapevine right here. Because of that, I would almost put this area in Bakersfield at a slightly higher risk because we see that sort of clustering. So another thing about is we look at deep quakes in other parts of the world, and this is why it's very tricky to forecast Southern California from my experience, is that when we look at other parts of the world, the subduction zone, which is where the two plates meet underneath the Earth's surface, is a lot deeper in other parts of the world than it is here. And we usually see, more often than not, we see a bunch of earthquakes in the 4 to 5 magnitude range a few days before a very large event, which would be 6 magnitude or 7 magnitude or higher. You'll typically see 4-pointers and 5-pointers occur at a depth, like if you look at the depth over here, they'll occur at a depth of like 100 kilometers or more. Because the subduction zone is so much closer to the surface than it is in other parts of the world, it's hard to determine whether or not they're precursors or not. If you look at all these, I mean, these are, if you don't look at this stuff, it probably doesn't mean much. But when you look at all these earthquakes around the world, like I have for like over a decade now, this is really shallow. These are all like pretty relatively close to the surface compared to other places. Like, just let me give you an example. If we go over here to like just Japan, let's say, 68 kilometers, 35 kilometers. And just so you know, 10 kilometers is the default depth that USGS uses when they don't have a measurement of depth. So whenever you see 10.0 kilometers, you can usually take it with a grain of salt. That's not where it is. But we usually see deep quakes. Let's see, what's this one over here? That's not deep. Oh, wow. Right here, we usually see deep, like, look at that, 569 kilometers. So that is pretty far beneath the Earth's surface. And in other places too. I mean, they're just a lot deeper. Look at 370, 140. Then we go back over here to the homeland, and it's like these are shallow compared to the rest of them. Anyways, point being, that's what makes it hard to determine whether or not the earthquakes we're seeing are precursors to a larger event. So what we could do from here is, why don't we go to the last major earthquake we had in California, like the real big one, was the Ridgecrest quakes. And just to give myself a little shout out and toot my own horn here, I did predict this one 6 days before it happened. I did a big write-up about it. I still have the Facebook post somewhere. I called it out. I had a discussion about Southern California just in general and how I think something was going to happen very soon. And sure enough, it did. So I just want to get the dates here. So July 4th, 2019. So you can go over here to USGS and you can do a search. You can search the earthquake catalog. So what we want is, we want a minimum of, let's say, 3.5. Usually for precursors, you want to go at least 4 magnitude. but I'm just going to do 3.5 just to kind of illustrate here what I'm talking about. We'll put the maximum at 6.0. And then we want this to be 2019. And let's just say July 1st, right? And then we will copy this, paste it down here, but we'll make this July, well, it happened on the 4th, right? So actually, let's go back. Let's go to June 30th up here. Because usually when we see precursors for earthquakes, you want to go about 5 days back. So 6, June 30th. And world, I think we got all that. We don't need, do we want depth? Okay, we don't have depth. Good. Now what's going to do is just going to show us what happens. So let's zoom into what happens. So if you look, so we'll go to newest first. So this is July 4th, July 4th. Look at all these earthquakes at about 4 magnitude, 3 magnitude. Look at all the shaking that happened. And so, I mean, how many are here? See, 43. I think that's 43, right? Yeah, it's about 43. 43 earthquakes in a 5-day period all occurred right there before we even got that 7 magnitude. So this is one reason why this one, fortunately for me, because I've been forecasting for 13 years and I've been paranoid as hell, like I said, because forecasting Southern California is, and the entire U.S. West Coast, in my opinion, is much more difficult than other parts of the world because of the shallow subduction zone. We don't know for sure that those are blot echoes, that these are emanating from the subduction zone that are going to lead the charge up into the surface. It's very difficult to determine whether or not these are precursors or if these were just the events themselves. But in this case, and I remember these started happening like literally the day after I did that write up on Southern California. The very next day or the day after that, I was like, look, I'm seeing something here. I think something's going to happen. So if we go back, you know, if we just go back to modern day here. Ooh, what happened here? Oh. Anyways, so this is where we're at. So, I mean, in the past 24 hours, we've had 3 right there, right? So let's change this to go for the past 5 days. So I'm going to search, and we're going to go past, let's see, starts, let's do the 7th actually here. So that's 5 days, and we'll change this to 3.5. And here we go. So are we seeing the same type of clustering? Not exactly. So, you know, in the past 5 days, like I said, in this area of Bakersfield right here, we've seen a lot more activity here. Now, this isn't 43 earthquakes. It's 10. It's still definitely significant and something I would keep an eye on. Is it as concerning as the Ridgecrest earthquakes? No. Not by much. I'm not saying this, you know, it's just, I think if you look, we had this 5.2, and then if you look, because this is in order by time, so the newest ones are on top, the oldest ones, they were getting smaller and smaller. You know what I mean? We haven't seen another one reach 5.0 yet. They got smaller and smaller and smaller, and then suddenly, you know, on the 8th, which is 4 days ago, there was a 4.4. We haven't seen anything since. So this area, you know, might be in the clear. I don't know. We zoom out a little bit more. There's just that one in Highland Park. You know, it could just be sort of an after effect of this one because all these plates are connected. This big Pacific plate is going underneath our North American plate right here. And, you know, I'm not seeing a big clustering. Is this something to keep an eye on? Yes, for sure. Is it something to be concerned about? I would say so. I would say always be prepared. Always be prepared. Just whatever you think you would need or want to prepare for in a major earthquake where suddenly you're not going to have electricity, running water, gas, or food for a few days. Be prepared for that. Be prepared for a week. Have a week's worth of food, water somewhere, and flashlights, batteries, and whatever you might need to get by and survive for about a week. If you always have that on hand, you have it all in one big bag, I would highly recommend too, so that if you need to bolt out of the house, you don't have to go, oh, the food's over here, the water's over there. No. Have it all in one bag. One bag somewhere, like in a closet, by the front door, whatever, right there, ready to go. You feel that shaking, you've gotten some alerts from me, and I'm concerned about stuff, or you have other people you want to follow, totally cool with that. If you feel like there's some indicators there that might be a major thing, just remind yourself that you have all this stuff by the door. And if you feel some shaking, grab that stuff and put it in the car. You know what I mean? That's the way it'll be safe in the car. If you really need to bone out and leave somewhere, you can, and everything you need will be right there. Keep your pets in mind too. I have 4 cats, and I also have 4 cat carriers that already have blankets and snacks inside them. Just in case something happens, I know they're going to be okay. And I share my water with them. So, yeah, I would keep an eye on this area for sure. It's we're not totally in the clear, you know, and we're still expecting some impact from another solar flare and that coronal hole. So those forces from the coronal hole will start affecting us. Let me get a look at it here. So whenever you see the coronal hole directly facing Earth, like right the center vertical line, it's going to take about 2 to 3 days for those forces to be in full effect and fully impacting the Earth at their highest peak. So over the next 2 days, I would just be paying attention if I were you guys. You don't have to look at all this satellite data. I don't think it's going to help you that much. If you guys want to learn, I will answer all your questions, and I'd be more than happy to nerd out and explain these things to all of you. I love this stuff. So I don't have a problem doing that. So, but for you, like if you just want to make this easy, you got other things to do in life. I get it. You don't want to watch this stuff. I get it. It's, trust me, just that's why I'm here. You can totally depend on me. You can just leave that up to me, and I'll just try to make it as easy for you as possible. I would just, if you want, go over here to USGS, earthquake.usgs.gov, and go to their earthquake map. And you can just look at it, and I would just pay attention for earthquakes. If you start seeing a bunch of small earthquakes clustering up over here in Highland Park, I would heighten the alert a little bit. I would heighten my awareness. I would be a little more concerned and more prepared, and just, you know, mentally prepared, and just, what am I going to do? What are these things? You know, I was going to go cave exploring tomorrow. Maybe not a good idea, you know, just things like that. Just whatever you could think of. Just follow USGS. If we start seeing a bunch of clustering, like I showed you with those Ridgecrest earthquakes, we had 40 small quakes in a 5-day period leading up to that. That was not hard to forecast. There was definitely a high expectation that something was going to happen there, and it did. That is what you will see. You can ignore 90% of all this other stuff that I do about forecasting if you want. If you really want to be pro and advanced about it and get up on game and be able to do it, again, I'm here, totally worth it. But if you just want the bare minimum, I would just always pay attention to that. There are usually, not always, you can't always depend on it. That's why I say it's probably better to do the more advanced stuff, is that there's not always a big cluster of earthquakes happening a few days leading up to an earthquake. Sometimes that doesn't happen. Sometimes you just get a big, nasty one. But more often than not, you will see a cluster of activity happening beforehand. So I would just pay attention to that. You can just zoom in on this area. You can keep a tab open in your web browser and just, yeah, you know, figure it out. And, you know, if you see a bunch of stuff clustering up, then it's something to be concerned about. And if you don't, it doesn't mean we're completely out of the woods. I would keep us on alert for, you know, the next few days till about the 16th or the 17th. I would remain on alert. So that's about it for today. If you have any questions, send me messages or whatever. Like, subscribe, all that stuff if you care to. It does help me out a little bit. So I think that's about it. Quake weather out.